Greetings to the respected faculty. Today, I want to discuss an essential concept in electrical and electronics engineering, the behavior of parallel circuits and their applications. As demonstrated in a project on parallel connection of two tube lights. Before I actually introduce the topic, I'd like to talk about the contributors and academic details. My name is Lasya Mandapati. I am from AI&ML B section. My roll number is 24951 A6686. This presentation is a part of the complex engineering problem for the course Elements of Electrical and Electronics Engineering with the course code AEED01. The faculty for this course is Mr. K. Lingaswamy with faculty ID IARE 10079. Now, this project, parallel connection of two tube lights, insights into the principles of parallel circuits, highlighting the reliability, fault tolerance, and efficiency. These are the ECs of the course, as well as the course outcome COs of the course. This is the abstract. So, basically, the study investigates the behavior and performance of two tube lights connected in parallel. This has been done using NI Multisim 14.0. The analysis covers three scenarios with two cases. The first is a bulb rated 120 watts with 120 volts with a 100-watt bulb. It is connected with a 144 ohms resistor to mimic a tube light. The second scenario is a bulb rated 120 volt and 250 watt with a resistance of 57.6 ohms, again to resist to mimic a tube light. See, this is because NI Multisim does not offer tube lights, and as you can see in later circuits, three cases. This analysis covers three scenarios where both the tube lights operate normally. One is experiencing failure and a complete voltage drop. The complete voltage drop, it has been mimicked directly by faulty voltages. The third scenario is basic of faulty voltage source, where it has been simulated with the wire being cut. Introduction. Now, parallel circuits, they play a vital role in electrical systems due to reliability and consistent use. Electrical circuits are the backbone of modern infrastructure. We all know this, powering everything from homes to industry. Among these, parallel circuits stand out for their ability to maintain consistent performance even under challenging conditions. This project explores how two tube lights behave when connected in parallel and examines their operation under different scenarios using the Multisim software. Project overview. The project simulates the parallel connection of two tube lights, as I've mentioned before. The objective is to analyze the performance of the circuit under varying conditions. Like I've mentioned, we've used three scenarios where both the tube lights are operational. The second is where one tube light is failing, and the third is a complete voltage drop. These scenarios highlight critical aspects of parallel circuits, such as consistent voltage across branches, current distribution based on resistance, and fault tolerance. The simulation provides valuable insights into circuit behavior, enabling a practical understanding of the parallel systems without physical components. And I'd also like to mention the version of the multisim used here is NI Multisim 14.0. Now, objectives. The primary goal of this project is to analyze the voltage remains to analyze how the voltage remains consistent across parallel branches, to evaluate the circuit's fault tolerance when one bulb fails, to study how voltage fluctuations affect when one bulb fails. No, to study how voltage fluctuations affect the brightness and functionality of the bulbs. To utilize multisim to simulate and analyze the circuit, bridging the gap between theory and practical application. Like I mentioned before, these are the prerequisites and requirements. And when it comes to prerequisites, there are three basic prerequisites: understanding the electrical components, like Ohm's law and basic laws, Kirchhoff law, a familiarity with the voltage and current laws, and circuit connections. As you can see, it is the ability to differentiate between series and parallel circuits with an understanding that parallel circuits maintain consistent voltages across branches. The requirements. Like I mentioned before, we are using NI Multisim software, the 14.0 version. Tube light representations. We are using a bulb with a resistance to mimic a tube light. Voltage source. The voltage source used here is a 230 voltage supply. It is used to mimic real world conditions. Measurement tool. Multisim's built-in tools for precise voltage, current, and power measurements. Methodology. The project is divided into three key scenarios, where, like I have discussed before already, the first one is where both the bulbs are operational. Here, the circuits are as designed. The circuits operator, the circuits operate as designed with both the bulbs glowing. The 100-watt bulb drew approximately 1.6 amperes of current, while the 250 watt bulb, as you can see here, it is the first picture. If you look, based on calculations, the 100-watt bulb drew approximately 1.6 amperes of current, while the 240 bulb, which is on the right side here, it drew around 4.0 amperes. The total current was the sum of the two, around 5.6 amperes. Next, when one bulb fails. In this scenario, when one bulb failed, the other continued to function independently. For example, if the 100-watt bulb is it's on the left side, bottom corner. If the 100-watt bulb was disabled, one of the 100-watt bulbs is disabled, the other one kept glowing. And here is the same for the 250-watt bulb. Even when one bulb is disabled, the other keeps glowing. Voltage failure. During a complete voltage drop, neither of the bulbs operated. This outcome highlighted the dependence of electrical devices on a stable power supply. Data from these scenarios was recorded in detailed observation tables, which validated theoretical principles like Ohm's law and the consistent voltage in parallel circuits. These are the simulation results. As you can see, the case 1, for the 100-watt bulb, both of them glow with a current of approximately 1.6 amperes. And case 2, where one bulb is failed, for example, like in the simulation, the wire is cut. So the one bulb fails. Current flows through only one bulb. It is shown that one bulb has 1.597 amperes of current, and the other has 0 amperes, which brings the total to 1.6 amperes. Lastly, voltage failure. Because of no voltage, uh, if you calculate using Ohm's law, I is equal to V by R. Current is 0, so total current is 0, and the bulb does not even glow. Similar results can also be seen for the 250-watt bulb. It has been mentioned in the paper, it's not in the PPT though. Uh, Discussion. The results confirm the key principles of parallel circuits: voltage stability, current distribution, and fault tolerance. In all scenarios where the circuit was operational, the voltage across each bulb remained consistent at 230 volts. This ensures uniform performance, crucial for lighting systems. Current distribution. The current through each branch was inversely proportional to the resistance of the bulb. The 250-watt bulb having lower resistance drew more current. And lastly, uh, fault tolerance. Even with one bulb failing, the circuit maintained partial functionality, ensuring uninterrupted lighting. These findings underscore the reliability and efficiency of the parallel circuits, especially in applications where consistent performance is crucial. This project, coming to the conclusion, this project serves as an excellent educational tool combining theoretical knowledge with a practical simulation. It benefits students and professionals alike. It does so by one, demonstrating how electrical systems behave in real world conditions, two, providing insights into designing fault tolerant and efficient circuits, three, encouraging the use of simulation tools like multisim for advanced circuit analysis. Future scope. While this study focused on two tube lights, future researchers could expand into one, for example, one, analyzing circuits with diverse loads to study scalability. Two, incorporating advanced components like ballasts and dimmers to simulate real-world systems more accurately. Three, exploring the effects of fluctuating power supplies and environmental factors on circuit performances. Such studies can deepen our understanding and drive innovations in electrical system design, making them more robust and energy efficient. I'd like to add a few more points to the conclusion. So basically, to conclude, the project on parallel connection of two tube lights highlights the robustness and practicality of parallel circuits by ensuring consistent voltage, accommodating independent operation of branches, and providing fault tolerance. Parallel circuits prove to be a cornerstone in modern electrical engineering. This study not only validates fundamental electrical principles but also offers a strong foundation for further research and application. And not just in any research and application, but research and application in designing resilient and efficient lighting systems. It is a reminder of how even the simplest concepts in engineering can have profound implications in our daily lives. These are the references I've used. They include Introduction to Electrical Circuits by uh, Farsi Suboda, National Instruments, the NI Multisim User Guide, Glover, JD Sarma, MS, and over by Power System Analysis and Design, IEEE Standards Association, IEEE Standards for Electrical and Electronics Engineering, Mehta VK and Mehta R, Principles of Electrical Engineering and Electronics by Ashan Publishing. These references provide functional and advanced knowledge relevant to the study of parallel circuits and lighting systems. Thank you for listening to my presentation today. I hope you have a very nice day.